All right, guys, we got one more compound inequalities, and again, I went with as many fractions and decimal problems as possible, because I know those are the bane of your existence. Again, a couple ways to do this. Now, this is an or, so you are literally just going to solve one inequality and then solve the other inequality and graph them both. But again, you've got a couple ways you can do this. All right, depending on how you feel, how comfortable you are, you can, if you would like, just add, oopsies, there we go, add 31 over 9 to both sides. All right, that is an option. And then that means you have 37 over 9 times k greater than or equal to, and you've got negative 31 over 9 plus 31 over 9. That's actually just a 0. And if you don't believe me, you can check it in your calculator. And then here's the deal. Everybody makes mistakes, but the one that we see as teachers the most often is we see when students divide by a number here. So we're going to divide by 37 over 9. It doesn't matter that it's a fraction. I don't care. It's okay. Dividing by 37 over 9 is the same thing as multiplying by 9 over 37. But the big idea over here is that 0 divided by a number is just 0. Now, that doesn't work when you do 0 divided by 0. Then it kind of blows up at you, and there's a big old undefined, and there's a big old proof in advanced mathematics that looks at it. But guys, anytime you take 0 and divide it by a number, the answer is 0. So whether it's an equation and you get k equals 0, or it's an inequality and you have k greater than or equal to 0, you still get an answer. It's not a no solution scenario. Okay? So you got to remember that k greater than or equal to 0, that is actually an answer. And just before I go on to the next one, actually, you know what? Maybe I'll do the next one a different way. Just remember, I'm not going to show you this, but you could have taken this entire inequality and multiplied everything by 9, right? And that would have gotten rid of your fractions, and then you would have had 37k minus 31 greater than or equal to 31, if you wanted to go that route. You don't have to. It's your call. I think on the answer key I did multiply by 9, so hopefully you'll look at that or get a chance to see that. But just to kind of give us some variety, I will do that over here. We're going to multiply everything by, my biggest denominator is 4. So I'm going to multiply everything by 4. So everything's going to be multiplied by 4. And remember, it's nice to write it out there, and then remind yourself that you are distributing it to everything that's in your inequality. And again, your calculator will do the work for you. Please remember that it is 4 times 3 divided by 2, 4 times 3 divided by 4, and 4 times a negative 2. Remember, this 4 is not multiplied both to the numerator and the denominator. That's not how that works. So 4 times 3 divided by 2 is 6, right? So you get 6k plus 4 times 3 divided by 4 is a 3, less than 4 times a negative 2 is a negative 8. So we now have a nice fractionless inequality. We are going to subtract 3 from both sides. 6k less than negative 11, and I apologize, that should have been in blue so you knew what I was doing there. Doesn't matter, probably shouldn't go back and mess it up, but I'm going to do it anyway. And then you divide by 6 here. Okay, again, we're dividing into a negative number, but not by a negative number. So k less than negative 11 over 6. Okay, I'm running out of space on the bottom. All right, and so when you go to graph this, you're going to graph 2 of them, and negative 11 over 6, if you run it real quick on your calculator, negative 11 divided by 6 is negative 1.83 repeating, so it's close to negative 2. So when we go graph that part, I'm going to do this we'll go with a nice bright green. We're going to be close to negative 2. We're going to do an open circle. This is so difficult to do this with such a tiny number line. And you're heading to the left, and then k greater than or equal to 0, will you do a closed circle at 0 and head off to the right. Okay, so that's good on compound inequalities. I'll do a couple absolute value and get those up for you in a little bit.